Thank you very much. Bacteria talk. There's a bacteria in the Caribbean called Vibrio fischeri. And every day, the bacteria in unison, all the individual cells create light. Now this is very useful for a squid called the bobtail squid, because the squid uses this light to camouflage itself from predators. But that's not the most interesting part. The most interesting part is, how do all the individual cells coordinate their behavior and turn on the light switch at exactly the same time? Because remember, there'd be no point in an individual cell turning on a light switch. It would be a waste of energy. No one would see the light. So it turns out that the bacteria communicate with each other. And they emit small organic chemistry molecules like this. Words, bacteria words. And other bacteria cells can receive that and interpret them. Now that's good bacteria, but we also have bad bacteria. Pseudomonas aeruginosa is a bad bacteria. And Pseudomonas infects the lungs of cystic fibrosis patients and has a very, very high mortality rate. And we thought, well, I wonder does Pseudomonas also communicate with each other? And it turns out they do. But they have ulterior motives. And one of the things that Pseudomonas want to do is they want to create a biofilm. And so they coordinate their behavior to create a protective biofilm that prevents antibiotics getting in. And so we were thinking, well, I wonder if we could create molecules, kind of like they use as their signals to communicate, like this, but make them slightly different. And so in this way, maybe we could confuse the bacteria and interrupt their communication. The same way as if you were talking to your neighbor and somebody else was speaking in your ear. And this turned out to work. And now we can prevent bacteria from creating these protective biofilms. We can interrupt their bacteria talk. But that's not the most important thing. The most important thing, and counterintuitively, is we don't kill the bacteria. So why is this a good thing? Well, if you think about how bacteria create resistance to antibiotics, you kill most of the bacteria, but the mutants survive. And the mutants pass on their genetic material throughout the generations. But if you don't kill the bacteria, then the mutant has no advantage. And that's our approach. So what we do is we try and learn the bacterial language. And by learning the language, we try and interpret it and confuse the bacteria. The real question, though, as an organic chemist and as a synthetic chemist, is what messages do you create? What words do we make? And how do we put the building blocks together to make those words? Thank you.